Hello, students. This is your first lesson in geometry. We're going to talk about basic shapes. So, what is the most basic shape in geometry? What's the most basic shape? The shape that all other shapes are made out of. Not a circle. Square? No. Triangle? No. The smallest shape, the shape that is inside of every other shape, is a point. A point. Point is the most basic shape in geometry. We label points with a capital letter. Points have no dimension. We can't measure them. They're infinitely small. They don't have a height or a width. When we draw them, they do. But when we talk about them, they're more of a concept than an actual thing. We can represent them with a dot on a piece of paper. What would happen if what shape can we make if we start to put a point next to a point, 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 next to a point in one dimension? What shape do we start to get? Yeah, we start to get a line. And if we keep putting points, it would extend infinitely in that direction and infinitely in that direction. So lines have one dimension. They don't have a thickness, they just have a length. So we can measure, we cannot measure them because they're infinitely long, but they do have a length. This could be line L. We've seen that before from algebra class. We can, when we draw this line, we usually call it line X. When we draw this line, we usually call it line Y. Seen that before. We can also put some points on the line because lines are made up of points. We can label them like QRS. So we can label lines like that. If I want to refer to line L, I could just choose 2 points on the line. So I could say, hey, I'm thinking of line RS, which means I'm thinking of a line that goes through point R and point S. So we would call this line RS. Line RS. We could also call it line SR, because if I start at S and go to R and then I continue infinitely in both directions, I still get the same set of points. It would be overkill to do line QRS. In math, we like to be efficient and we do not need 3 points. We only need 2 to define that shape. So what can we do with a line? Well, there's actually not that much that we can do with a line. We can, like I said, name it. In algebra, we can do more stuff with lines. So I could name this line M. We can talk about pairs of lines. That's going to be coming up in a little later. In algebra class, we can find the slope of a line, which is we can find the equation for a line. So especially if a line is on a coordinate plane like this, I can say, oh, I can find the slope. And I can say, oh, this line crosses the y-axis at 2, and the slope is down 1 over 3. So the equation of this line, maybe we'll call it t, would be t of x would be negative 1/3 x for the slope, and then plus 2 for the y-intercept. So those are some things we did with lines in algebra. What about a part of a line? Here's a line. And what if I only want not the entire line? What if I only want the section of the line from here to here that begins here and ends here? If I only want these points in here, this shape, it has a beginning point and an ending point. Okay, that would be a line segment. That would be a line segment BE. Now, when I write that, I don't have arrows on the end because it's just part of a line. With line segments, we can do a bunch of different things. One of the main things we can do with a line segment that we can't do with a line is measure it. So if there's a line segment on this paper, we'll call it line segment HI. Hi. So the name of this line segment is line segment HI, or I could call it line segment IH. Those are the only two names for this set of points from here to here. Okay, and what you can do is you can slap a ruler up next to it. So I can just take this ruler and slap it up right next to this picture, and I can say, how long is this line segment? This is called the ruler postulate. So we can, the first shape that we can measure is a line segment. So if I slap this ruler up next to it, I can say that point H is at 3 and point I is at 10.5. Okay, I can use those numbers to tell me the length of HI. The length of line segment HI is equal to just HI. So it's kind of, in geometry, this gets a little confusing, and the worksheet I'm giving you actually doesn't do a very good job at this. But if I want the length of line segment HI, I just write HI with nothing on top of it. It means it's a number. And then what can I do? I can take the 10.5 and I can subtract it from the 3. So the length is going to be 10.5 minus 3. And then I have these lines right here. These lines mean absolute value. In geometry, we have a lot of positive numbers. We don't have a lot of negative numbers, because when we're talking about geometry, we're talking about distances. So how long would it take to walk from here to here? How many steps? You would not step a negative number of amount. So 10.5 minus 3 is 7.5. 7.5 or 6.5? 7.5. 1, 2, 3, 4, 5, 6, 7.5. So the answer is 7.5. The length of line segment HI is 7.5, or you could say HI is 7.5. This is called the ruler postulate. It says you can slap a ruler on a line segment. You can use the numbers on the ruler to tell you how long the shape is. Now, if we're smart, we don't put the ruler right there. We actually line up one of the endpoints with the ruler right there. My dog is barking. That's exciting. And you can also see 7.5. Then you don't have to do all this math. Okay, here's a math problem. It says, well, let's just take a look at this. What's the smallest line segment up here? What's the smallest line segment? This one right here. Oops. This one right here looks pretty small to me. Line segment ED. Line segment ED is the smallest. So another thing we can do with line segments is we can compare them. We can say some are short and some are long. So line segment ED looks like it's the shortest. If I want to find the measure of line segment ED, I can straight up say, I can count it and just 1, 2, 2. Line segment ED is 2. Has a number that's 2. Its shape is the set of points from here to here, and the number that goes with that shape is the number 2. Okay, what's the next biggest line segment on here? Maybe BC, 1, 2, 3. BC equals 3. Are there any line segments up here that are the same length? Two, three, four. DB or BD is 4. 4 minus 0 is 4, so that makes sense. DC, line segment DC has a length of 7. How about line segment AE? Yeah, so this line segment right here, like this, from there to there is one line segment, happens to be the same as from D to C. Those are equal, they're both 7. It takes 7, 1, 2, 3, 4, 5, 6, 7. Oops, I went too far. I have to erase some of that. Okay, that's 7 long there, and that's 7 long there. So another thing we can do with line segments is compare them. And the comparison here is that line segment AE is 7, and line segment DC is also 7. So we can say that AE is the same shape and the same size as line segment DC. They're both line segments, so they're the same shape, and they have the same number, so they're the same size. So this symbol right here, same size, is equal. They're both have a 7 as a number, and this little squiggle on the top, it's on your keyboard. It's up by number 1 somewhere probably. This is called a tilde. It's a little squiggle. Okay, that means same shape. So this symbol is congruent. It means same shape and same size. Okay, here's a math problem that we can do with line segments. It says that points F, G, and H are collinear. What do you think collinear means? What's the prefix and what's the root word? The root word is line, and co means together. So F, G, and H are together on the same line. And you can see in the picture that F, G, and H are all in a straight line. And they're all on this line together. Now it says that GH, from G to H, this part is 16 long. So the length of line segment GH to get from G to H is 16 steps to get from there to there. So what are we trying to find? We're trying to find FH. FH is longer, isn't it? So whatever my answer is has to be bigger than 16 or I did something wrong. So we have GH is 16. We're trying to find FH, which we don't know. But we do have some algebra right here. So we have that 16 is the same length as 2x plus 2. So what we do here is we, this is in geometry textbooks, you will see this all the time. They'll throw in some variables, and the reason they're doing that is to help you practice your Algebra 1 skills, because they know that you're going to take Algebra 2 soon. So we try to keep your algebra skills fresh by putting them into geometry problems. So we know that GH equals 16. We also know that GH is 2x plus 2. Okay, so we can set an equation. We can say that 2x plus 2 is equal to 16. And then this is some algebra, so we want to solve for x. So one way to do that is to take away 2 off of both sides. Some teachers let you put the minus 2 underneath. I don't like to do it that way. If you do it that way, that's fine. If you can do some of this in your head, that's fine too. And divide both sides by 2. That means x is 7 steps. Remember, it took 16 steps to get all the way across. 2 times 7 is 14, plus 2 more is 16. Okay, now, in algebra class, we are done. Yay, we found x. We don't have to do anything else. But in geometry class, we are not done. We have to go back and say, hey, what was it that we were trying to figure out? And often that means after you find x, you have to go back and read the problem and see what it is the heck that they want. Okay, in this problem, they wanted FH. Well, x is not FH. FH is a lot bigger than 7. So how can we find it? We can find it in 2 ways. Okay, you could find FG, which is 3x minus 1 is FG. And now we know what x is, so we're going to substitute in the 7. And that's 21 minus 1, which is 20. 20. 3 times 7. Now I'm hesitating because that really doesn't look like it's 20 long. So this is a really crappy figure. This is supposed to be 20 steps right here. Okay, did I do something wrong? I don't think so. Okay, so we still need to find FH. So we could do the segment addition postulate where we say that FH is the same as FG plus GH. So FH, the total, is the same as from F to G, which is 3 times 7 minus 1, plus 16, which is 2 times 7 plus 2. So we just do 20 plus 16 and gives us 36. FH equals 36. 36 steps to get from there to there. All right, that's the lesson. Be good, do your homework, and I will see you next time.